So number 1 says, for 1 through 3, we're finding the equation of the circle in standard form and determine its center, radius, and state the domain and range. So, okay. So for this first problem, first off, you need to get all the x's together and all the y's together. Let me reorient this. Okay. Okay, I think it's going to work. All right, so I'm going to put the x squared with the negative 12x and then plus a blank, plus y squared plus 40y plus a blank equals, move the 75 over, so subtract it, plus blank plus blank. And yeah, of course I could start it over further, but I will. All right, and next what I'm going to do is complete the square for both the x and the y. I'm trying to get this to focus. There we go. Okay, so I've got something squared for x plus something squared for y equals, and okay, I cut the negative 12 in half and I get negative 6, and then the only way that this whole trinomial equals this is if the last term is negative 6 squared, so I'm going to add 36 to both sides. Okay, and then I cut 40 in half and I get 20, so plus 20, and then 20 squared is 400, and so I'm going to add 400. So then I've got 436 minus 75. 436 minus 75, so that is 1, and then 43 minus 7, so 36, 361. Okay, so as far as my center, we're opposite of what it, on the interior, opposite of what it is. So it's positive 6, negative 20. So if you go right 6 and down 20, there's the center of the graph. And then the radius is the square root of 361, because the formula is x minus h quantity squared plus y minus k quantity squared equals your radius squared. And so if this is radius squared, if 361 equals radius squared, then radius equals the square root of that. Now, 361 is actually 19 squared, so my radius is 19. Okay, so as far as my domain and range, so the point of your circle is that it's centered. So let's go right 6, down 20. Yeah. So if I want to find my domain and range, the radius is left 19, right 19, right? So I subtract 19 going to the left from 6. So you can get 6 minus 19, which is negative 13. And then 6 plus 19, which is 25. All right. As far as range is up and down. So I'm going to go down 19 from negative 20, so that's negative 39. And then I'm going to go up 19 from negative 20, and that puts me at positive 1. And there's my domain and range. Okay, number 2. So on number 2, I've got x squared. I do not have an x term, so I could leave it like that, or I could put plus 0x plus, if you just want to like write that to remind yourself of what you're doing, and then subtract the 6 over. But either way, this right here is just going to be x, if you want to do plus 0, or just do x squared, right? It's going to be the same thing. So plus y quantity squared, okay, plus, so I already know this one's 0 and 0. 8 cut in half is 4, 4 squared is 16, so plus 16, which makes this right here, negative 6 plus 16, a 10. All right, so I've got x squared plus y plus 4 quantity squared equals 10, which means my center is the point 0, negative 4, opposite on the inside, and then my radius is the square root of 10, because if r squared equals 10, then radius is just the square root of 10. So as far as domain and range goes, so domain is your x value, right? And our x value is 0. So if you take 0 and you subtract square root of 10 and you add square root of 10, so from 0 you go square root of 10 on both sides, your domain is just negative square root of 10 to positive square root of 10. Now your range, you go from the y value. So we went 0, negative 4. So there's my center. If you go up and down the square root of 10, which is, square root of 10 is a little bit greater than the square root of 9, which is 3. So, I mean, it's just a little bit more than that, but you're just adding the square root of 10, right? So it's, and then subtracting the square root of 10. So you take your center, negative 4, and you subtract square root of 10, and you add square root of 10. And there's your range. Okay, let's talk number 3. Number 3 has a leading coefficient of 4, which is not desirable when we're trying to do circles. You want to get rid of that. So we're just going to divide everything on both sides of the equation by 4. Okay. So I've got x squared plus y squared plus 3x plus 11y minus 39 fourths equals 0. So then I'm going to reorder everything. X squared plus 3x plus blank plus y squared plus 11y plus blank equals, I'm going to add the 39 fourths over, plus blank plus blank. Alright, so let's fill in what we know. Okay, I'm going to take the 3 and cut it in half, so x plus 3 halves squared. When you square 3 halves, you have 9 over 4, so we're going to add 9 over 4 to both sides. And then this one right here is going to be y plus 11 halves squared. And 11 halves squared is 121 over 4. So square the top, square the bottom. So I'm going to add 121 over 4. And so then these all have a common denominator already, which is convenient. So then I have 121 plus 9, which is 130, and 130 plus 39 is 169 over 4. So my center of my circle is at opposite, negative 3 halves, negative 11 halves, or negative 1.5, negative 5.5. And then if radius squared equals 169 over 4, then that means radius is the square root of that. And the square root of 169 is 13, and the square root of 4 is 2, which means my radius is 13 halves. Okay? So as far as domain and range go, domain, I'm going to write it out like what I'm going to do, and then I'm going to simplify, okay? So domain, you take the center, the x center value, right? And you subtract the the radius, and you add the radius. So we subtract and add the radius, going left 13 halves and going right 13 halves from your center point. But then that actually simplifies to negative 16 halves, and that is negative 8. And this simplifies to 10 halves, which is positive 5. So my domain is negative 8 to 5. Range. So range, we take the y value, negative 11 halves, and you subtract the radius, and then you add the radius. So we're going down negative 13 halves from negative 11 halves, and then we're going up 13 halves from negative 11 halves. Negative 11 minus 13 is negative 24, and negative 24 halves is negative 12. And then that is just a positive 2 halves, which is 1. So my range is my domain is negative 8 to 5, and my range is negative 12 to 1. Okay, and there's the circle problems. So let's grab some piecewise. All right, my function is broken up by less than negative 3, between negative 3 and 2, and greater than or equal to 2. So I'm going to mark it off. So negative 3, between negative 3 and 2, and go from there. Okay. So the left-hand function is this quadratic, and it is a quadratic shifted to the left 5 and up down 2. Sorry. So I'm going to go And I'm to the left 5 is on the other side of -3. It's on the left-hand side of -3, so we're good to graph the vertex. So go to left 5, down 2, and there's the vertex of my parabola. Okay? Well, as far as that goes, a parabola just has a normal pattern, you know, just, so you go over 1, up 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then same on both sides. So 2, 4, 3, and 9. So I'm going to go from my vertex over 1 up 1, over 2 up 4. Now that I'm going to reach -3 when I go to the right 2, and that's not included. So when I go over 2 and up 1, 2, 3, 4, I'm going to leave that open. Okay? And then I'm just going to graph on this side until I'm done. 5, 6, 7, 8, 9. Okay? So on this side, or in this portion, I have this parabola. All right. So let me go ahead and write that down. X plus 5 plus b squared minus 2. All right, in the middle part, I have this horizontal line, or horizontal, well, just a function too, a constant function, which is a horizontal line. It also does not exist at -3, and it does not exist at +2, so that means an open circle again. Okay. And then for this last part, I have a linear function, 4x minus 5. The y-intercept is not on my interval. I mean, I could go to -5 and then just like ghost draw it until I get to the point I need. But the easiest way to do this is to just plug in 2 and then go from there. So 8 minus 5 is 3. So I know at 2 I should be at 3. And that is defined, so that's a closed circle. And then I'm going to travel my slope. My slope is up 4 over 1. 1, 2, 3, 4 over 1. And so then just connect, and there you go. There's my function. As far as continuity goes, this function is continuous everywhere except both -3 and 2. So I'm going to write it's continuous for all real numbers except -3 and 2. Now, then you got to address like what is happening at each of those. So at x equals -3, I have a removable discontinuity because it's just a hole in the graph. Like they still go to the same point, it's just that it doesn't exist at that moment. So there's a removable discontinuity. At x equals 2, it actually jumps from one y value to another y value, so that is a non-removable jump discontinuity. Okay. Number 5. All right. This, well, it breaks it up into 4 parts. Less than -2, between -2 and 3, between 3 and 7, and then greater than 7. So let's graph those functions. So the farthest one on the left is the greatest integer function. Yeah, or the 4 function. Oop, let me go there. Okay, so greatest integer function says that you are that number until you're the next number, right? So if I'm going to the left of -2, I'm going to go ahead and go to -8 and think about that. At -8, I am -8 until I am -7, and then I'm -7 until I am -6. Then I'm -6 until I am -5. I'm -5 until I'm -4. I'm -4 until I'm -3. I'm -3 until I'm -2. Now, normally I would put a dot right there, but we said only up to -2. We don't actually include it. So that is the end of that piecewise function, or that step function. Okay. So you are the number where you're at number 4 and -4 until you are -3, and then you're -3. All right, the next one is a linear function. 3 has x. So we are actually going through the y-axis, which means I could graph its y-intercept. I actually want to work this 2 different ways. So one way to do this is to plug in your endpoint. So if I plug in -2, I actually get -3. So I know that this function, this linear function at -2 is -3. it still doesn't exist there, so I'm going to leave that as an open circle. Okay. And then when I plug in 3 halves times 3, I get 9 halves, which is 4.5. So at 3, I'm going to go to 4.5. 1, 2, 3, 4.5. And that is a closed circle. Now, because it's a linear function, all I need to do at this point is connect them. So if you do that, then you don't have to actually, I mean, a linear function between two x values, all you gotta do is plug in the endpoints and then connect them with a line. Now, if I actually like plotted the y-intercept, like it's 3x plus 0, right? So if I plotted 0 and then went up 1, 2, 3 over 2, that would get me to this point, and down 3 left 2, yeah? But it wouldn't get you necessarily to there. Now, if you had this point and this point and this point, you could connect and then just continue going until you reached it. But this is a little bit more final, like that is for sure 4.5. Okay. The next part of it is this square root, which is kind of an involved one. Okay, so let's talk about the square root. Normally a square root is, let's draw it over here. Normally a square root looks like this, yes? Well, when you have a negative, that means it flips it over. And then this minus 3 means go right 3, and this plus 6 means go up 6. So we're talking about something like that, right? So normally the pattern on a square root is over 1, 1, the square root of 1 is 1, the square root of 4 is 2, and the square root of, actually I don't think we need to go that far, but 9 is 3. But then there's a 2 in the front, which is a vertical stretch by a factor of 2, so that means go to the right 1, go down 2, go to the right 4, go down 4, and 6 if I can reach it, but I don't think we do. So I'm going to go to the right 3 and up 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. That is an open circle. This has got to be because that's closed. I don't know why I counted up 6 when there's a scale on the side, but that's fine. Okay, I'm going to go over 1 and down 2. To the right 1, down 2. And I'm only graphing it until 7. So if I go to the right 4, 1, 2, 3, 4, that puts me at 7 down. 1, 2, 3, 4. That is a closed circle right there. Or an equal to, so that means it will be a closed circle. So then we just connect. Oh, there's Luker. Okay, my last function on this is, I don't know why I put 1/2 times, but it is 1/2 the absolute value of x minus 11. Okay? So let's talk absolute value function for a second. Absolute value function just looks like that. This is up 1 over 1, up 1 over 1, up 1 over 1, the same, like the whole time, constant slope of 1. And this is up 1 to the left 1 or down 1 to the right 1. You know, either way, that's a slope. This is a slope of -1, this is a slope of +1. Well, when you put a 1/2 in the front, that literally means when we graph it, you go up 1 over 2, up 1 over 2, and then you just go in the opposite direction on this side. Up 1 to the left 2, up 1 to the left 2. Okay? So I'm going to go to the right 11, which is what that minus 11 means. Put a point. I'm going to go to the right 1, or sorry, up 1 to the right 2, up 1 to the right 2. I'm going to go up 1 to the left 2, and up 1 to the left 2. Now technically that means that, you know, that means open circle, but there's already a closed circle there, so it's not like it changes anything. So then we just connect and extend it off the page, and there you go. There's your piecewise function. As far as continuity goes, this function is continuous on all real numbers, except continuous on all real numbers except. Okay, so we've got every integer less than or equal to -2. I'm going to go ahead and state this one. That one's continuous right there, but that one's a jump, so 3. And let me do it don't know how I say that. Because I've got two different things, but I'll say. How about I do this? Continue to all our numbers except x equals 3 and x is less than or equal to -2. And let's say integers. Integers less than or equal to -2. Okay? As far as what we need to identify them as, okay. For all integers less than or equal to -3. So at -3, we have a jump discontinuity. At -4, a jump. At -5, a jump. At -6, a jump. But at -2, we don't have a jump. So that's why I said -3. There is a non-removable jump discontinuity. And then for x equals -2, I have a removable, because there's just a hole in the graph, discontinuity. And then I have another jump at x equals 3. Non-removable jump discontinuity. And then we're continuous everywhere else. Okay, and that's piecewise. Now, I will say, if you're watching this video, now I'm gonna say this, but then if a lot of people show up doing this on the test, then I will not give the bonus, okay? Because I do not expect very many people to watch this video. But if you do watch the video, then if you draw a triangle when you do the piecewise graph, if you draw a triangle with a smiley face on it or in it, then I will give you a bonus point for watching this video. You need to keep that to yourself, because if a lot of people start doing it, I will not give the bonus point, okay? Because that means you're just telling people to do it. I want to reward the people that actually watch the video, and we don't talk about it. We don't talk about it before. We don't talk about it after. You just do it. I give you a bonus point, and no one has to know anything, okay? All right. Number 6. Number 6 is, it says using the rational root theorem, find all the roots of the following polynomials. So, rational root theorem says I need to find the factors of the constant, 1 and 40, 2 and 20, 3, 4 and 10, 5 and 8. So, all those divided by the factors of 9, 1, 3, and 9. Well, I like 1, 3, and 9 because that tells me I have whole numbers, I have thirds, and I have ninths. So you have only these whole numbers, any thirds, 2 thirds, 4 thirds, 5 thirds, 8 thirds, 10 thirds, and then any ninths. So I'm probably not going to do a ninth, but anyway. All right, let's graph it. I've got 9x raised to the 5th power minus 57x raised to the 4th power plus 100x raised to the 3rd power plus 22x squared minus 104x plus 40. I'm going to press zoom 6, just have a standard window, see what happens. Okay. Yeah, I think actually turning on a light helps. It's a little darker. On the screen it actually lights that. Okay, so here we go. I'm going to zoom in between -2 and 2 on the x. So I'm going to go -2 to 2. And on the y, I'm going to go -2 to 2 as well, just to really zoom in on there. So it looks like -1. And then it looks like it bounces, right? So remember, I only have whole numbers, thirds, and ninths. So when I look at this, I look at it and I think, that could probably be 2 thirds. And in fact, because it bounces, I'm going to try 2 thirds twice. So I'm thinking -1 and 2 thirds with a multiplicity of 2. Okay, so x equals -1 and 2/3 multiplicity of 2 question mark because I gotta prove it. We'll find out after it's true. All right, so let's try -1 first. -1, 9, 5, 4, 3, 2, 1, 9. We're not missing any terms, so be careful about that. -57, 100, 22, -104, and 40. Drop the 9, that's -9, that is -60, oh gosh, 66? Yeah, that was bad, almost. 66, 166, so -166, so -144. So then positive 144, which means 40, which means -40 and 0. Alright, now I'm going to do 2/3. So 2/3, drop the 9. 1/3 of 9 is 3, and 3 times 2 is 6. So that's -66 plus 6, which is -60. 1/3 of 60 is 20, so 2 times -20 is -40. 166 minus 40 is 126. 1/3 of 126 is 42, and 42 times 2 is 84. 144 minus 84 is -60, -144 plus 84. Yeah, -60. 1/3 of -60 is -20, and -20 times 2 is -40. And there we go. Now I'm going to remember, because I synthetically divided by a fraction, to just cut these numbers in thirds. So that's 3, that's a -20, that is a 42, and that is a -20 again. So now I'm going to do synthetic division with 2/3 again. So drop the 3. 1/3 of 3 is 1 and then 2, so -18. 1/3 of -18 is -6, and -6 times 2 is -12. 42 minus 12 is 30. 1/3 of 30 is 10, and 10 times 2 is 20. And I'm going to remember to divide by 3. So 1, -6, and 10. Which means I am trying to solve the quadratic x squared minus 6x plus 10 equals 0. There are not factors of 10 that add up to -6, so I can do completing square. So x minus 3 quantity squared. 3 squared is 9, so add 9 equals 19. X equals 3 plus and minus the square root of 19. Or I can do the quadratic formula. X equals opposite b plus and minus the square root of b squared minus 4 times a times c all over, how am I going to get, oh my gosh, that's -10. I'm tired. I was like, wait a minute, what's something wrong? So -10 plus 9 is -1, and the square root of -1 is I. Cool. I'm glad I checked. I'm glad I did both. Okay, whatever. 2a. Cool. 6 plus and minus the square root of, that's 36 minus 40. It's 4 times 1 times 10. So that's -4 over 2, which means 6 plus and minus 2i over 2. Divide both things by 2. You get 3 plus and minus I. Wow, Jennifer. That was bad. All right, so my roots are, for sure, -1, 2/3 of the multiplicity of 2, and 3 plus and minus I. And there we go. Okay. Last problem. Okay, so number 7. It says, using the given root and the rational root theorem, find all the roots of the polynomial. Now, I'm going to go ahead and work it out from the very get-go. That's going to be a lot of multiplication. That's going to be fun. But my other option is to graph what I have, graph the function given. So 24x raised to the 6th minus 76x raised to the 5th minus 26x raised to the 4th minus 9x raised to the 3rd plus 87x squared plus 50x minus 50. So I know that there are 6 roots because the degree is 6. I know 2 of them, 2 plus or minus the square root of 2 from that right there. So I need to find 4 more. Oh, just kidding. So let's see. Alrighty then. I'm going to zoom in from -2 until 1, 2, 3, 4, -2 to 4. -2 to 4. And I'm going to go -2 to 2. See what happens. Yes, okay. Alright, alright. Okay. So, I don't know about you, but looking at that one. I'm pretty sure that's 1, right? And then I've got this one and this one. So let me think of my options. You know what? I'm not even going to worry about it until I divide out the 2 plus or minus the square root of 2. Pretty sure 1 is a root, but I don't particularly want to do this the factors of 50 divided by the factors of 24. Although the 24 is going to hang around to stay, which is cool, but whatever. Okay. So let's do this. 2 plus the square root of 2 divided into 24, negative 76, negative 26, negative 9, 87, 50, negative 50, and there we go. All right, so drop the 24. 24 times 2 plus the square root of 2, so that's 48 plus 24 square root of 2. 76 minus 48, 76 minus 50 is 26, so 28, negative 28. Negative 28 plus 24 square root of 2. All right, I need to multiply that out, so I'm going to go over here. And I'm going to change bins. It's 2. Okay, so 2 plus the square root of 2 times negative 28 plus 24 square root of 2. All right, I've got 2 times negative 28, that's negative 56. 2 times 24 square root of 2 is 48 square root of 2. Negative 28 times the square root of 2 is negative 28 square root of 2. And square root of 2 times 24 square root of 2 is 24 times 2, which is 48. So negative 56 plus 48 is negative 8. Yes, negative 8. And 48 square root of 2 minus 28 square root of 2 is 20 square root of 2, so plus 20 square root of 2. All right, negative 26 minus 8 is going to be negative, so 4, negative 34. Negative 34 plus 20 square root of 2. All right, now I need to multiply again. Okay, 2 plus the square root of 2 times negative 34 plus 20 square root of 2. All right, here we go. 2 times negative 34 is negative 68. 2 times 20 square root of 2 is 40 square root of 2. Negative 34 times the square root of 2 is negative 34 square root of 2. And square root of 2 times 20 square root of 2 is 20 times 2, which is 40. So negative 68 plus 40 is negative 28. I did not make myself number. And then 40 squared root of 2 minus 34 squared root of 2 is 6 squared root of 2. All right, negative 9 minus 28. So negative 9 minus 28 is negative 37. Negative 37 plus 6 square root of 2. Okay, so 2 plus the square root of 2 times negative 37 plus 6 square root of 2. 2 times negative 37 is a negative 74. 2 times 6 square root of 2 is 12 square root of 2. Negative 37 times the square root of 2 is negative 37 square root of 2. And square root of 2 times 6 square root of 2 is just 6 times 2, which is 12. Negative 74 plus 12 is negative 62. Negative 62. And 12 minus 37 is negative 25 square root of 2. All right. 2 plus the square root of 2 times, I gotta add them first. 87 minus 62 is 25, so 25 minus 25 square root of 2. Right? 25 minus 25 square root of 2. So I've got 50 minus 50 square root of 2 plus 25 square root of 2, and then minus 50, which is interesting. So the 50s simplify out, and I'm left with negative 25 square root of 2, which does not combine, so it becomes 50 minus 25 square root of 2. So I've got 2 plus the square root of 2 times 50 minus 25 square root of 2. I've got 100 minus 50 square root of 2 plus 50 square root of 2, and then minus 50, 25 times 2. And so that's 100 minus 50, which is 50. Yay. I will try and keep the numbers reasonable. I mean, you'll have a calculator, but the smaller the better, because then there's not as much room for error. All right, so now I'm going to divide out 2 minus the square root of 2. Okay. Well, now we're back to red. That's boring. Okay, sorry. Probably like, okay. All right, drop the 24. 24 times 2 minus the square root of 2. So 24 times 2 is 48, and 24 times negative square root of 2 is negative 24 square root of 2, which simplifies down to just 20. 20 times 2 is, just kidding, it's 40. And then 20 times negative square root of 2 is negative 20 square root of 2, which leaves me with just 6. 6 times 2 is 12, and 6 times negative square root of 2 is negative 6 square root of 2, which leaves me with just negative 25. Negative 25 times 2 is negative 50, and negative 25 times negative square root of 2 is positive 25 square root of 2, leaving me with just negative 25. And negative 25 again is negative 50 plus 25 square root of 2, which is 0. Okay. So, I'm used to get rid of a factor of 2. Oh well, whatever. So I'm going to graph this. It's probably going to cross in the same spot, but maybe it'll be a little bit different. 24x raised to the 4th, because I divided out 2 degrees, right? So it's 24x to the 4th. Plus, just kidding. Plus 20x raised to the 3rd, plus 6x squared, minus 25x minus 25. And graph. Oh, Okay, that's nice. So the 2 plus the square root of 2 and the 2 minus the square root of 2 were two of those rational roots we were seeing at the very beginning of the problem. And now I only see 2 more rational, which means the other, well, okay, those are the irrational roots I was saying, the decimals. But now I'm only seeing the rational roots, which is really nice because I don't have to worry about even like trying to find ones that match these. And then I know that a total of 6. Here I've got 2 more, so that's 4, and then 5, 6 are probably imaginary. Not probably, I mean they are. Okay, so I need to find those. Here we go. I need the factors of negative 25. I'm just kidding. I was about to say the divide by. I need to figure out all the factors of negative 25, or just 25. So 1, 5, and 25. That's pretty easy. Factors of the constant divided by the factors of the leading coefficient, which is 24. Oh gosh. 1, 24, 2, 3, 4, 6, 8, 12, and 24. Okay, so my options are all of these divided by 1, 1, 5, 25. All these divided by 2, like 1/2. Okay, I'm just going to kind of go through and think about what they could be. This is not 1/2. It's not 1/3. It's not 1/4. It's not 1/6. These all get progressively smaller, so it's not one of those. 5. It's not 5. It's not 5/2. That's 2.5. 5/3 is 1 2/3. 5/4 is 1 1/4. 5/6. It could be 5/6. Let's try it. So I'm thinking 1 and 5/6. 5/6 is really close to 1. Oh, just kidding. Negative 5/6. And so that's what we're going to go with. So let's divide out the 1 first, because that's easier. Drop the 24. 1 times 24 is 24. That's 44. That's 44. That's 50. 50. 25. 25 and 0. So 1 does work. And now we're going to do negative 5/6. Probably not with this pen. Okay, 24 divided by 6 is 4, and 4 times negative 5 is negative 20. That is going to be a 24 again, and 24 gave me negative 20. 50 minus 20 is 30. 30 divided by 6 is 5, and 5 times negative 5 is negative 25. Okay, I'm going to remember to divide by 6, so that gives me, Jennifer. Divided by 6, it gives me 4. I was thinking about that one. 4 and 5. So I've got 4x squared plus 4x plus 5 equals 0. And that is the last equation I need to solve. So I'm just going to do quadratic formula, call it good. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's 16 minus 16 times 5, which is just 4 16s. But anyway, I'll go ahead and work it out. Instead of 16 times 5, I'm going to think 20 times 4, which is 80. So 16 minus 80 is negative 64. So negative 4 plus and minus the square root of negative 64 over 8. Square root of negative 64 is 8i. And then divide everything by 4. And that gives me negative 1 plus and minus 2i all over 2. So my total roots are x equals 2 plus and minus the square root of 2, 1, negative 5/6, and negative 1 plus and minus 2i divided by 2. And there you go. Okay. I hope this is helpful. So one last thing, if you're watching this video, if you complete all these problems on another piece of paper and turn it in and staple it to your review, then you will get some bonus points. Okay, good luck. And again, with that whole thing, completing them and stapling them, Um, I don't expect everyone to do that. So if a lot of people do it, I'm assuming that y'all just told. So, okay. All right. Thanks.